Hello and welcome to my video, lesson 1.2b, where we're talking about the graphs and equations of polynomials. So there are first a few things you have to know from 1.2a, and some of those topics include zeros, which are x-intercepts. We need to understand multiplicity. And with those two main ones, we can do most of these things. But I highly recommend looking back at that video if you don't know what I'm talking about. Okay, so let's go ahead and get started here. So one of the rules here, when we're looking at a graph to kind of figure out some of the equations of this graph, we're going to call this graph f of x, okay, is that we have to look at the multiplicity of any of these points. So if the point is, or of the zero. So if the zero is going right through the graph in a straight line, we call that a multiplicity of 1. That means that the binomial will have degree 1. If it curves like this and touches only at one point, then it has a multiplicity of 2. And if it does this kind of funky thing here, then it would have a multiplicity of 3. Okay, and you can check these out by going y equals x equals x squared, and y equals x cubed. They're kind of, if you just plug those into your calculator, those will show you the different multiplicities of each of those situations. So if we look here at our graph, we have two zeros, and this first one has a multiplicity of 2. Because if you look at it locally, i.e. from here to here type of thing, then it is basically a quadratic, is kind of what it looks like. Right? But if you look at this other point, it's a multiplicity of 3, because again, from here to here type of thing, it looks like a cubic function. All right, so we know those 2 points. So we can go like this. So x plus 3, and this point is from right here, has a multiplicity of 2. So the degree has to be 2. And then the other point is x minus 3. And this has a multiplicity of 3, so it has degree 3. Why am I putting this a in front? This is a coefficient in front, a leading coefficient that'll be in front of the x terms, and in fact in front of everything, but it'll be right in front of all of our binomials. So how can we figure out what that leading coefficient is? Well, once you've looked at all of your multiplicity and 0 points, then all you need is one more point, and we have that right here, and we can use that point in order to solve for our a value, our leading coefficient. So let me show you how that will look. F of x equals, and we're going to look for, no, instead of writing f of x, we're going to write the y value here, which is negative 3, equals a, which is what we're looking for. And x is the 0 value here, plus 3 squared. X is a 0 value, minus 3 cubed. All right, and now we are going to solve for a. So that would be 9a, negative 27, negative 3. So let's move everything over, and we'll get a very, very small fraction. So if we move the negative 27 over, it cancels the negatives, and it's like 27 divided by 3, which gives it a 9. And then we could move over the 9, and again, that would be dividing by 9 to keep opposite operators, and so we get 81. So 1 over 81 is the value of a. So then what you finally do is you plug that back in, because most questions won't actually ask you for find the leading coefficient, what it will say is find the equation of the function below, or function of f of x, or whatever it'll say. So what you actually mostly usually have to write is this whole thing, which would give us the graph that we have in purple. All right, we're also going to look at a couple basically word problems essentially here. So let's take a look here. Jimmy wants to increase his storage space by 392 feet squared by extending the walls equally in all dimensions. If the original shed was 5 by 5 by 6, write a polynomial to model this situation. Since I'm doing this on my tablet, I actually don't have my graphing calculator to show you, but I'll tell you guys the steps for B. But A, you don't need your calculator. What we need to do is, if we're extending equally in all dimensions, and these are the original dimensions, right? This should say feet cubed. There. So it's a volume. If we think about originally, or our actual equation is volume equals length times width times height, right? Now in this case, the original is 5 by 5 by 6, right? So what we need to do is extend the walls equally in all directions. So we're going to go plus x plus x plus x. So every dimension has this plus x being added to it. Okay, and we could even simplify this a little bit more and say x plus 5 squared, x plus 6. So what he wants to have is 392. Okay, so what we need to do is we need to plug this into our calculator. So what we are going to do is in y1, we're going to put this in our calculator. So I'm going to talk it through. I don't have my calculator on my tablet to show you guys, but we would do exactly this. All right, and then you'll see that you'll have some sort of graph, and because it's a leading coefficient that is positive, it's probably going to go up. Well, it will go up into this direction. There's also degree 3 is the highest, so it'll go down and do something like this. I don't know exactly what it is, but something like that. So probably something like that. So if it doesn't add anything, it has some sort of volume, but then we're looking to see at what point will the volume be the right amount. So we want the volume to get to this 392, right? So what we're also going to do is plug in our y2 as 392, and that will give us a line that goes across something like this. All right, and then what we need to do is find the intersect. So we use second function, calc, just calculate, and then intersect, and then move the cursor to the right point and hit enter 3 times. So the little blinking cursor should get to this point here. And let's just see if I can figure that out really quickly here. And what you should find is that x, so like if we're thinking x comma y, right? X is going to be 2, and y will be the 392 that we're looking for. Which is great, but we're not quite done yet. This is just our x value, right? So what should he add for every direction? Okay, so I guess, yeah, we could just leave it there. So we're going to add 2 to every direction. The other way the question might be worded is, what are the new dimensions? So you'd have to write 7 feet by 7 feet by 8 feet. Both ways are pretty common to be asked. Probably the what are the new dimensions are probably a little bit more common. All right, let's take a look at this next one here. 3 consecutive integers have a product of 336. Write a polynomial function to model this situation. So 3 consecutive. Like always, if you guys can pause the video, try it out yourself. That would be better. I'm going to go ahead and do this for you guys. Pause it whenever you want. So 3 consecutive integers, meaning that they are one after each other. So 1, 2, and 3 would be consecutive, but it could be like 4, 5, and 6, whatever, right? They have to be one after each other. It could also be negative, so -2, -3, -4. Those are consecutive, although I kind of have the order kind of backwards from all the other ones. So 3 consecutive integers. What do you notice about the integers that I just wrote down? Well, hopefully you can notice that they are actually all just the original value, right? 1, and then 1 plus 1 is 2. So, and then 1 plus 2 is 3. So if we write this in this form here, n plus 1, n plus 2, those are 3 consecutive integers. N is the first integer, n plus 1 is the second integer, n plus 2 is the third integer. So 3 consecutive integers, and this would work, have a product of 336. So what it's saying is this has to equal 336. Okay, so again, we can solve it just like we did in the last question, right? Where we simply go y1 equals n plus 1, n plus 2, and y2 equals 336. And then what you need to do is go second function, calc, intersect, and then move your cursor to the right point and hit enter 3 times. Okay, I figured it out. So if you do all that correctly, you should get the values of 6, 7, no, that would be our final answer, I guess. 6, 7, 8. So when you actually do this, you'll get your x, y, which would tell you that your n value is 6, your y value is 336. So with the 6, we have to recognize that that's actually just this value of n, which is actually our first value, right? So if we're thinking about 3 consecutive integers, now we can go n plus 1, which is 7, and n plus 2, which is 8. So if we're asking what are the 3 integers, we need to write this down, not just our intersect point. So anyways, this is the other half of 1.2. I hope this video helped you guys better understand, especially unknown leading coefficients, how to get them, and some problem solving with polynomial functions. Hope this video helped, and good luck.